Hello, pre-algebra students. This lesson is going to be on graphing proportional relationships. This is part 1 of this lesson. There will be a video as well for part 2. For the warm-up question, this part here comes from yesterday's lesson. If you have not watched that video on independent and dependent variables, you should watch that first. And that lesson we talked about, based on a situation, can you write equations, create tables, and create graphs to go with that story? Go ahead and use what you learned in yesterday's lesson to help you with this warm-up question. Pause the video now to try it, and then come back to get the answer. For this first part, in order to write this equation, we need to first identify what math is happening in the story. When it says she can read 2 pages every minute, that means you're multiplying 2 by the number of minutes that she reads. I could show that in my equation with 2m, where m represents the number of minutes she reads. In order to be an equation, we need this to equal something. So I could say 2m would equal, maybe I use the letter p, and p is going to represent the number of pages read, or your total pages. This would be the first part of this problem, and we can use everything we said here to help us with our table and graph. Now, one of the things we had learned yesterday when we talked about independent and dependent variables is how to correctly set up a table and a graph. We said when you create your table, this first column is always your independent variable, and the second is your dependent variable. So in order to make my table, I need to know which is independent, which is dependent. Since the number of pages she reads depends on how many minutes she reads, that means P would be my dependent variable and M is my independent variable. So when I go to set up my table, I'm going to say this first column represents M, or the number of minutes she reads, and my second column is P, or the number of pages she reads. So for example, if she reads 0 minutes, she's read 0 pages. That should make sense. After 1 minute, we know she's reading 2 pages each minute. 2 minutes would be 4 pages. 3 minutes would be 6 pages. And we can continue that pattern to make our table. Remember, when you create a table, you don't have to go in order like this. You could jump to 10 minutes if you want, as long as you're doing that multiplication to get the total number of pages. When you create your graph, again, we need to know which is independent and which is dependent. We learned in yesterday's lesson that this x-axis right here is always going to be your independent variable. So that means my x-axis is going to be the number of minutes she reads, and my y-axis is going to be the total number of pages she can read. You can either use this table here or use your equation to help you find where those points are going to be. Since we already have made this table, I can start marking my points. There's a point at 0, 0. There's a point showing after 1 minute she's read 2 pages. After 2 minutes she's read 4 pages. And we can keep going like that to create the graph of our line. This is where we had left off yesterday's lesson. The goal for today is really focusing in on being able to create these graphs of these lines. We call them linear equations. The difference today is instead of you having a story and using the story to help you create the graph, I'm just giving you an equation with no story, and we have to create the graph. So you can kind of see our first example is going to look something like this. In order to create those graphs, there's something you can notice about the connection between this graph and our equation. Looking at our equation, the way we got the table and the way we got the graph, it was all about this number right here, this number 2. With our graphs, the 2 is going to help us know what direction our line is going. That 2 came from 2 pages every minute. So it meant when I went to graph my line, every single time we were going up 2 pages after every 1 minute. You can see my line goes up 2 boxes after 1 minute after 1 box. That too is going to be super important when it comes to making these graphs when we don't have a story. So for example, you're going to see problems in this lesson that look like this. It says create a table for the equation y equals 2x and then graph the equation below. Just like above, that 2 is going to help us create our table and create our graph. When you go to set up your table, we've got x and y are our two variables here. Some of the points we mentioned up here are also going to show up in this table. For example, if I make x the number 0, the equation tells me how I find y. In order to find y, I'm going to do 2 times the number I chose for x. And so y equals 2 times 0. That's 0. For example, if I make x the number 1, same idea. My equation says y equals 2x. So 2 times 1, y would be the number 2. And you could keep going with that. 2, y would equal 2 times 2. So y equals the number 4. Notice it's the same points we have in the table above. The difference here is earlier, all of our numbers were positive because you can't have negative minutes and negative pages. But here, there's no story keeping me from using negatives. So you could also choose a negative number if you wanted. You could choose a number like -1. The same idea, I could replace x with the number -1, and we're going to get -2. The pattern is whatever number I put here, I'm just multiplying it by 2 to get this answer every single time. So if I put -2 there, multiply it by 2, and we get -4. Or if I put -3 here, what would this number be? -3 times 2, -6. The pattern this equation is describing is the same as above. The difference is instead of talking about minutes and pages, we aren't talking about anything. We're just talking about x and y. Similarly, the graph to this equation is going to look really similar to the one above. And the way I would know that, again, is all about that number we see in the equation. My equation says y equals 2x. That 2 is going to be what tells me how my line moves. Just like above, the 2, if you think of it like a ratio, 2 is the same as 2 over 1. You know that because 2 divided by 1 is 2. To make something look like a fraction, you're always putting it over 1. This is telling me then that my line should be going up 2 boxes and over 1. I want to go up 2 and over 1. Looking at our table, I see the point 0, 0. So just like before, my line is going to start at 0, 0. And it is going to go up 2 boxes and over 1. Up 2 boxes and over 1. And as I mark those points, notice those are the points you have in your table over here. We've got a point at 1, 2. We have a point at 2, 4. The difference with this graph is it also is going to go into the negatives. So I would have a point at -1, -2. I'd have a point at -2, -4. We get this big long line here. I'm going to go ahead and use this to make sure my line is straight. And so we end up getting this graph right here. It is very similar to the one above, except it goes through the entire coordinate plane because we now have these negative numbers as well. These are the type of problems we're going to be looking at in part 1 and part 2 of this lesson here, is how you graph these equations when you don't have a story. I know sometimes people don't like story problems in math class, but I think for a lot of us, it is easier to make a graph when you have a story. It's a little harder when you're just looking at this math equation and not having a situation to help you make sense of it. But we're seeing the biggest, most important part of that equation is that number 2 right there. And because it is so important, it has a name. We call that 2 the slope. Slope is a number, like the number 2, and it tells you the direction of the line. When we talk about slope, a lot of times we talk about it with the formula rise over run. Just like when I had 2 as my slope and I thought of it as 2 over 1, that top number in the fraction tells you the rise. So that tells me how much we're going up. The second number in the fraction tells you the run. So that told me how many boxes I was going over. When you're looking at slope, you're always thinking about it with rise and run. So we graphed the equation y equals 2x. My question for you is, how would our graph change if I asked you to graph y equals 3x? Go ahead, pause the video now and either create that graph or think to yourself, how would this green line look different if we were doing y equals 3x? Pause the video and then come back when you're ready to get an answer. For y equals 3x, my rise would be 3 and my run would be 1. So the difference here is instead of going up 2 boxes, I would be going up 3 and still over 1. So up 3 over 1, up 3 over 1, up 3 over 1. That would look more like this. I'm going to go ahead and put the line through it so you can see. It would be this graph right here. So it would look different because your line would be a little steeper. It would be a little more higher or up and down. There's a second story we're going to look at to help us think through these graphs a little more. So we're going back to Susanna. Again, this comes from yesterday's lesson where you're given a story and I want you to think through what the table, equation, and graph would look like. Go ahead, pause the video now and see how much of this you can do on your own. Come back to the video when you're ready to get some answers. In order to finish this table and to help us with the equations and graphs, question A is super important. Just like in that first question where we knew she was reading 2 pages each minute, in order to do this problem, I need to know here how many pages can she read in 1 minute. Be careful, this first pair of numbers is saying it takes her 2 minutes to read 1 page. It's not the answer to this question. But we can use that to help us figure out the answer. If it takes her 2 minutes to read 1 page, when I'm reading that pair of numbers, I'm picturing in my head 1 page. So this is 1 page in her book. And it's taking her 2 minutes to get through the entire thing. If it's taking her 2 minutes to read that 1 page, how many pages is she reading in 1 minute? Well, in 1 minute, she's getting halfway through that page. So after 1 minute, we are going to say she has read half a page. How many pages can she read? She can read half a page per minute. And that half a page per minute is where these other pairs of numbers came from. Half a page per minute is also going to be the most important thing we need to write our equation in our graph. Thinking about what you've already done, when I told you she could read 2 pages per minute, that was the warm-up question, you took that and wrote the equation P equals 2M. What would half a page per minute look like in an equation? Well, that would be the number of pages equals half per minute. The only difference here is we're told we want to use y for the number of pages and x for the number of minutes. So instead of p and m, our equation would be y equals 1/2 x. Now this is different from the ones you did above because there's a fraction. And I know so many of us see fractions and go, oh, I hate fractions. I never understand fractions. I don't like them. But think about what we were doing earlier. When it comes to graphing, fractions are a good thing. We were taking our 3, our slope, and you were making it a fraction, even though it didn't need to be a fraction. When it comes to slope, fractions are good. So here, when we're asked to graph this equation, the fact that it's already a fraction makes my life easier. I can see my slope is the fraction 1/2. And so that is going to tell me my rise and my run. That is telling me I need to go up 1 box and run 2 boxes to get our graph. So when we do that, I'm going to start again at 0, 0, because just like we said before, if she reads 0 minutes, that would be 0 pages. And using my slope, I know the next point is going to be up 1 box and over 2. It would be right here. Now, I also could figure out that point from our table. My table is telling me after 2 minutes, she reads 1 page. So after 2 minutes, she reads 1 page. That's just that point. We can keep doing this. I can keep rising 1 box, run 2 boxes, rise 1 box, run 2 boxes, up 1, right 2, and that's going to give me the rest of my line. Your graph for this situation would look something like that. This right here is what the second part of this video is going to be on, is how we graph these equations that have fractions in it. And we're seeing it's the same way we were doing them before. I'm just thinking of rise and run with that number. So the final piece to this is let's switch over to equations that don't have any story to help us with our graph. It's all going to be about that slope, the number you see in the equation. So again, one final time, pause this video and think through how you would graph these 2 equations. If you have graph paper at home, that's awesome. You can try to graph it yourself and then come back to the video to get the answers. To help us with these graphs, I went ahead and wrote rise over run because that's going to be your best friend. In order to graph this equation, I see my slope is 2/3. So if I match that with the words rise over run, that is telling me my line should rise 2 and run 3. I'm going to start this equation at 0, 0, just like the others, and I'm going to rise 2 boxes and run 3. That would be right there. Rise 2, run 3. Rise 2, run 3. And then I've got enough points to go ahead and make my line. When you go to graph these equations, first of all, make sure you draw a line. The answer to this graph is a line. It's not these points here, but it's the full line. And make sure your line goes across the entire graph like this. Again, since there's no story, it means I can have points over here on the negative side. So we want to make sure that line goes all the way across. Now for this final one here, notice I don't see a number right there, but you have learned in a past lesson what number there is in front of a variable if you don't see one. This would be the same thing as y equals 1x. So that means my slope is 1. And since it's not a fraction, to make it a fraction, I'm going to put it over 1. Same way we did above when we had our slope as 3. 3 over 1, 2 over 1. Here it would be 1 over 1. So that means when I go to graph my line, it should be going up 1 box and over 1 box. Again, one final time, I'm starting at 0, and I'm going to go up 1 box, over 1 box, up 1, over 1, rise, run. And so you don't need all of the points, right? Once you have this many, you can see where the line is. Our line would be right here. In this first part of this lesson, in part 1 of this lesson, I'm trying to say in the first video on this lesson, we looked at equations where the slope is a whole number, like 2 or 3. Then we looked at equations where your slope is a fraction, like 1/2 or 2/3. The final part of this lesson and what you're going to see in part 2 in the second video, can you guess what it is? We have not seen any equations where slope is negative, and so that will be the second part of this lesson. So make sure you watch that video as well to see how our graphs change when slope is negative. Thanks so much for watching. I hope this helped. Have a great day.